either force into displacement or P into dA wala. Just check. 139, cylindrical bubble or cylindrical drop. Liquid drop or liquid bubble is same to same. Suppose this is a cylindrical drop of length L, radius R. If we increase its area, surface area, that means throughout this will be the increase. That means work done is P into force into this displacement dr. Correct? This is nothing but pressure, excess pressure into area. What will be this area? Surface area 2 pi r into L. Total area will be this much 2 pi r L, curved surface area,
Yes, sir.
into dr, equation 1. Now increase in area dA is nothing but 2 pi r, this part we are taking 2 pi r plus dr into that length L minus 2 pi r L. So 2 pi r L plus 2 pi p r L minus 2 pi r L. So therefore we can say work done is P into dA, which is P into 2 pi RL into equal to P into 2 pi L dr. 2 pi L, 2 pi L we can cancel. 2 pi dr into L. Here also there is one dr. So P equals to P by R. For cylinder it will be P equals to P by R. Okay, clear the solution? Understood?
Yes, sir.
Then 147.
Done, sir.
147 now you want, huh?
Yes, sir.
147. A thread is tied slightly loose to a wire frame. So this is frame, thread is tied here. Distance of solution listed frame is completely covered in fill with A is punctured. A is punctured. That means there is no fill na after puncturing. Only the fill will be here na when it is punctured.
Yes, sir.
The portion A is punctured with pin, then thread will become what? If it is punctured, then thread will become what? If A is punctured, then this will be pulled downward, na, like this, due to this force. correct? Right? This is the film. So force due to surface tension will pull this, na, inward this way.
Yes, sir.
So that means it is concave this side. Concave towards A. Concave towards A option is given.
Done, sir.
Now this till 155 everything is done.
Yes, sir.
I will send you one more sheet only of surface tension that you will try as a homework. Today's test is on atoms, molecule, nuclei. Coming Monday test will be on only light chapter. That means all 4 chapters. Or you can say it is lens, prism, then wave theory, interference. So ray optics and wave optics test on next Monday. Now I'm starting with very simple chapter of heat, that is first radiation. Easiest chapter of heat, radiation. In how many way heat can be transferred from one point to another?
Three types:
What are they? Conduction, convection,
convection and radiation.
radiation. Radiation is the fastest mode which does not require any material medium. So radiation mode of transfer of heat in the form of electromagnetic wave. Mode of transfer of it in the form of electromagnetic wave from body at high temperature to the body at low temperature is called as radiation. Now, can you tell me what are properties of radiation? They can travel through vacuum with speed of light. They lie in infrared region 7,500 to 250,000 angstrom unit. Third, they obey law of reflection and refraction. Just copy this much. Hello. Yes. Good afternoon. Oh, अच्छा. हाँ, no problem ना. तो 12 तो रहेगी ना वो. नहीं, कोई बात नहीं ना. तो क्या करें? जब भी लेक्चर होता है थ्योरी का, तो तब वो बैठेगी. बाकी टाइम पे नहीं बैठेगी. नहीं, मैं उसको एक्स्ट्रा अकेले 2 वीक हफ्ते में ना 2 दिन लेता हूँ खाली, क्योंकि जब मैं सिखाऊंगा तो फास्ट होगा, तो इससे थोड़ा होता है टाइम में. तो खाली जो 12 का हम उनको संडे संडे में उसको बुलाते हैं, खाली संडे संडे भी करा दूंगा तो उसका फास्ट होगा. लेकिन जब वो दे ही नहीं रही है तो कुछ नहीं लेना. नहीं वो कैसे था, अगर जितने भी अपने बच्चे सारे नीट वाले हैं ना, नीट और इंजीनियरिंग वाले हैं, तो अभी उनका जैसे इलेक्ट्रोस्टैटिक था मैंने उसके साथ कर दिया। अब वो चैप्टर भी इसके बाद जो मैं सिखाऊंगा उसमें स्टार्ट होगा वो साउंड से, नाम है चैप्टर का वेव, तो उसके साथ हो जाएगा। नहीं मैं बताता हूँ, इलेक्ट्रोमैग्नेटिक वेव एंड सेमीकंडक्टर, वो तो 2-2 घंटे के चैप्टर, वो जो चैप्टर है ना वो खाली, अब जब बोले हाँ आ गया, लेकिन वो चैप्टर नहीं रखा है। नहीं नहीं मुझे कोई प्रॉब्लम नहीं है, मैं तो आपका इंतजार कर रहा था, फोन कैसे करोगे, कैसे हम आगे बढ़ेगा ना। मैं आपको बाद में रात को कॉल करता हूँ, फिर हम डिसाइड कर लेंगे टाइमिंग वगैरह। नहीं मैं आपसे बात करने के लिए ना, कैसे हम डिसाइड करेंगे ना, क्योंकि मैं अभी समझो सुनिए, अगर वो खाली 12 दे रही है तो उसे 3 दिन के लेक्चर की जरूरत भी नहीं है। वो खाली संडे अगर 2 घंटा भी स्पेयर करे तो वो उसका हो जाएगा। आप बात कर लो, फिर मैं आपको इवनिंग में 8:30 के आसपास कॉल करता हूँ, फिर हम डिस्कस करके वी विल गो अहेड ना, टेक द कोर्स ऑफ इट। देखो कैसे होता है कि 12 हम वो मैं उसको कुछ मुझे टाइम नहीं लगेगा, मुझे तो वो रोज संडे में हो जाएगा। देखो ऐसे होता है ना, देखिए सुनिए क्या होता है, एक एमसीक्यू होता है 11th लेवल का, वो एमसीक्यू नहीं होता है, वो जो आप थ्योरी पढ़ते हो उसमें से वो लोग एक ही टाइम से रीजन आएंगे, और जो एमसीक्यू होता है एंट्रेंस का उस पर डेप्थ होता है ना, इसलिए तो हमको एक चैप्टर करने में कम से कम 25-30 डेज लग जाते हैं। अभी तक मेरा इलेक्ट्रोस्टैटिक खत्म है, वो बड़ा चैप्टर है। तो 11th वाला जो वेव साउंड वाला है वो तो 3 घंटे में मैक्सिमम हो जाएगा, तो मैं इवनिंग में आपको बता दूंगा, क्योंकि खाली मैं उसको अकेले सिखाऊंगा ना चैप्टर, तो हम कैसे कर सकते हैं वो मैं 10 आवर्स का आपको बता दूंगा, तो उसमें वो पूरा खत्म हो जाएगा। तो इसका 11 फिर उसका दिन का 11 खत्म हो जाने दीजिए इस बार, कॉलेज का एग्जाम, उसके बाद 12th भी मैक्सिमम एक संडे और एक कोई भी दिन दे तो भी वो हो जाएगा, क्योंकि अगर खुद से पढ़ेंगे ना थोड़ा टर्मिनोलॉजी डिफिकल्ट होती है, और जब टीचर समझाता है तो एक्सपीरियंस उसको ईजी कर देता है, इतना फर्क पड़ता है। ठीक है, आप बात कर लीजिए, देखिए आपसे नहीं नहीं कोई बात नहीं, अब मैं हमेशा भी आपको बात करता हूँ, फिर मैं एक बार से आपसे डिस्कस कर लेता हूँ कि ये टाइम पे हो सकता है क्या, और हम निवा से डिस्कस कर रहे हैं कि प्लीज कंफर्टेबल विद दैट टाइम इट विल गो अहेड। हाँ ठीक है, देखो जब तक कम्युनिकेट नहीं करेंगे कुछ समझेगा नहीं ना। हाँ हाँ वो अच्छा ठीक है मैं करता हूँ, ठीक है। रिटर्न दिस वन।
Yes, sir.
See, whenever we represent heat incident on surface, we will write that as Q. So if Q is heat incident, which is actually nothing but electromagnetic wave, their behavior is similar to light wave. Part of heat will get returned back, means reflected back. Part will go in other media, and part will be absorbed. So how much out of Q is absorbed, how much reflected, how much transmitted, means we have to compare. In physics, comparing is called as ratio, and it is termed as coefficient. So we should know what is coefficient of absorption, denoted as A. It is ratio of radiant energy absorbed to that incident. Then coefficient of reflection, denoted by R. It is ratio of radiant energy reflected to incident. Then coefficient of transmission, denoted as D. This is ratio of amount of radiant energy transmitted to absorbed. So whenever it is asked coefficient of transmission or absorption or reflection, it is nothing but ratio of heat energy absorbed upon incident, reflected upon incident, transmitted upon incident. Okay, just write these 3 lines.
Done, sir.
If Q is total heat incident, it is partly absorbed, partly reflected, partly transmitted. If I divide throughout by Q, I get QA by Q plus QR by Q plus Q2 by Q. This gets cancelled. So 1 equals to A plus R plus T. Write this formula.
Done, sir.
What is perfectly black body? A body which absorbs almost all the radiant energy incident upon them. A body which absorbs almost all the radiant energy incident upon them are called as perfectly black body. That is, coefficient of absorption is emissive power. Emissive means to emit. Whenever it is power means always it is with respect to time, like rate of doing work. So the amount of radiant energy emitted per unit time, comma, per unit area. Amount of radiant energy emitted per unit time per unit area at given temperature is called as emissive power. It is given by E equals to Q upon H. Its SI unit is Joule per meter square second or watts per meter square. Sometimes they can ask you dimension of emissive power. What will be dimension of emissive power? What is, or from here we can say Joule is energy M1 L2 T minus 2, and this is L2 T1, so it will become M1 L0 T minus 3. M1 L0 T minus 3. Just completed it. Other, I can take a future next month of design. Later. 549, 545 का रखा, नहीं बैठ रहा है, हाँ कितना, अच्छा अच्छा, तो ये अपना कितना दिया है, 30 है, निकाल दीजिए, हाँ निकाल, अभी वो आगे दे देगा, ठीक है, करेगा, ठीक है.
Yes, sir.
Coefficient of emission. Or also called as emissive. The ratio of emissive power of any body to the emissive power of perfectly black body. Ratio of emissive power of any body to the emissive power of perfectly black body is called as coefficient of emission or emissivity. It is given by small e equals to E upon E. So emissive power of any body to that of black body is called as coefficient of emission or emissivity. Write this definition.
Sir, emission and transmission are same.
No, emission is different. ट्रांसमिशन is different. ट्रांसमिशन अभी देखो कैसा है, एक पाइप मैंने चालू कर दिया पानी से, तो पानी आगे आगे जा रहा है ना,
Yes, sir.
वो ट्रांसमिशन है. एक टैंक में पानी रख दिया और नल लगा दिया बाद में, तो वो एमिशन है. मतलब एक में कैसे होता है, कंटिन्यूअस फ्लो होता है, और एक में आपने पहले एब्जॉर्ब किया और बाद में फ्लो देखा. दिस इज बेसिक डिफरेंस.
Done, sir.
Black the body which absorbs almost all the radiant energy incident upon them is called as perfectly black body. Here A is 1, R is 0, T is 0. So perfectly black body means it will only absorb, it won't reflect, it won't transmit. Then athermonious body, a body which transmits all the radiant energy, incident upon them are called as a harmonious body. means A is 0, R is 0, and T is 2. Just copy this two, then one more, then we'll start.
Done, sir.
I, a Therminius body, a body which does not transmit radiant energy incident upon them are called as diatherminious body. Therefore, here A plus R is 1 and T is 3. Carries black body or artificial black body. Carries black body or artificial black body. It consists of double-walled hollow sphere with small opening called as aperture. There is conical projection opposite to the aperture. So here only important is why conical projection be. So if surface is black and if light is incident, normally it will retrace the path in the same direction. But if it is kept inclined like this and light is incident parallel, then you can see that except at this place, it is making some angle with normal. So it will get reflected back into the same medium. So with this conical projection, we ensure that light gets reflected not along the same path. Inner surfaces are coated with lamp black. When light is incident on inclined surface, it undergoes internal reflection. So just write the terminus body and perfectly black body. Conical projection का इधर मैं use निकाल देता हूँ. Conical projection prevents heat loss due to reflection along same path. Right. Then
Yes, sir.
Kirchhoff law of radiation. At same temperature, this is important, at same temperature, coefficient of absorption is always equal to coefficient of emission. That is A equal to, then Prevost's theory of heat exchange. This is important. Every body will radiate, means it will give, as well as absorb. That means it will give also, it will take also. So every body will radiate as well as absorb the heat at all temperatures except at absolute zero temperature. Body at higher temperature means more than that the surrounding, will radiate more. That means it will give more than it accepts, will radiate more, hence it will lose heat. Just copy this, two more points we have to write.
Done, sir.
So रिवोट सीरीज says that कुछ भी टेम्परेचर होने तो बॉडी देगा भी हीट और लेगा भी एट ऑल टेम्परेचर एक्सेप्ट एट एब्सोल्यूट जीरो। हायर टेम्परेचर है तो ज्यादा देगा कम लेगा, इससे टेम्परेचर उसका बॉडी का हीट it will lose the heat, temperature will decrease. When body is at lower temperature than surrounding, lower temperature, then it will absorb more heat and its temperature increases. When body is at same temperature, then it will absorb and radiate at same rate. Hence, temperature will remain constant. This is called as thermal equilibrium. Okay. Write this 2 points.
Done, sir.
Yes, done.
Yes, sir.
Next, black body spectrum. Black body spectrum. The graphical representation of energy emitted with wavelength at constant temperature is called as black body spectrum. When wavelength is increased, it is found that energy emitted increases, becomes maximum, and then again decreases. When temperature is increased, then for same wavelength, energy emitted increases, becomes maximum, and again decreases. So this was lambda corresponding to maximum energy emitted in first case, and this is lambda corresponding to maximum energy in second case. So we can see that as temperature is increased, wavelength corresponding to maximum energy emitted is decreasing. So we can say wavelength is corresponding to maximum temperature, maximum intensity is inversely proportional to absolute temperature. So black body spectrum means graph of energy against wavelength at constant temperature. It is as shown. From the above graph, following conclusion can be drawn. First, the spectrum is continuous but not uniform. Just draw the diagram and write first one. अभी कितना दो? नहीं नहीं अपना ही है. हाँ हाँ हाँ. 550 हो गया 40 का. तो 45 में रखो क्या ले लो? क्या बोल रहे हो? है ना? हाँ हाँ. जान दो रुक जाओ. 45 देखते हैं दूसरा कुछ लेते हैं अगर इसमें. Draw this graph, then first point write down. Second point as wavelength increases, energy first increases and then decreases. Lambda maximum is proportional to 1 by 2/4 area under graph is energy emitted.
Done, sir.
Hence, displacement law. Wavelength corresponding to maximum energy emitted is inversely proportional to its absolute temperature. That is lambda maximum is 1 upon T. So this is P upon T, where T is constant called as Rain's displacement constant. Its value is 2.898 meter Kelvin. Right.
Done, sir.
Stefan's law of radiation. Again, because it is radiation means it will emit something. But it is defined for perfectly black body, even though it can be used for any body. The rate of radiation, that is heat radiated per unit time, comma, per unit area by perfectly black body is directly proportional to the horsepower of its absolute temperature. That is dq by dt A is proportional to T raised to 4. So dq upon dt A is some constant. Here it is sigma T raised to 4, where sigma is a constant called as Stephen's constant. Its value is 5.67 into 10 raised to minus 8 joules per second meter square Kelvin raised to 4. Joules per second meter square Kelvin raised to 4. Just copy it in there. Done?
Yes, sir.
Okay. Everybody is done. Can I clear it off?
Yes, sir.
Yes, sir.
अभी थोड़ा 10 मिनट का ही काम है, ये पूरा theory खत्म हो जाएगा. So dq by dt is a sigma t raised to 4 for any body, for perfectly black body. If you multiply this by E, then this becomes amount of heat radiated for any body. Black होगा तो E you put 1, you will get required answer. Now if body is kept in surrounding of temperature T naught Kelvin, then it will give more and take less. So net heat radiated will be difference. So I can say dq by dt will be A E sigma T raised to 4 minus A E sigma T naught raised to 4. Therefore dq by dt will be A E sigma T raised to 4 minus T0 raised to 4. So this is formula by using Stephen's law of radiation to get heat radiation. Now copy till then. Then it is Newton's law of cooling. So theory over. Next lecture I will start with MCQ of this. So Friday, Thursday test on fluid mechanics. Some only 1 to 60 के बीच. 1 to 60 I will give just 25 questions. Fluid mechanics 1 to 60.
Done, sir.
Newton's law of cooling. It states that the rate of loss of heat is directly proportional to the excess temperature of the body over surroundings. The rate of loss of heat is directly proportional to the excess temperature of body over surroundings, provided excess is small. Therefore, dq by dt is directly proportional to excess temperature. Provided excess is small, it should be less than equal to 40 degrees. So dq by dt is some constant into theta minus theta. Just copy this much. This is our Newton's law.
Done, sir.
So one.
Done, no?
Yes.
Just 5 lines more, then we'll stop. Since we all know that heat is also mass into specific heat into temperature. So dq by dt, mass cannot change when heat is given out. Specific heat cannot change, only temperature is reduced. So this is K into theta minus theta 0 is M S d theta by dt. So we can say d theta by dt is K upon ms into theta minus theta. Now K is constant, M is constant, S is constant. We can denote it as C. So K upon mass into specific heat is equal to C equals to constant. Therefore d theta upon dt is C into theta minus theta 0. So d theta upon dt is directly proportional to theta minus theta. Thus, rate of fall of temperature is directly proportional to the excess temperature of body over surrounding. So not only rate of loss of heat, even rate of fall of temperature is directly proportional to excess temperature of the body over surrounding, provided excess is small. Right.
Done, sir.
So that's all for today. We'll stop here. Tomorrow, timing you are knowing, na? Tomorrow's timing.
So tomorrow